Hello everyone. Now I will talk about the protocol analyze and the events of the Underwood application Sandbox multi-layered security investigation. Abstractly, the project aims to provide a head on a depth exploration of the Underwood security models, current application science installation. We will develop a suite of test application and use standard development and security tools to empirically verify the event measurements of the underweight sandbox at each layer from the links kernel to sinks Linux and runtime permission model. Fourth, the project will explore the boundaries of this solution by designing and testing proof of contact application that attempt the pipes those controls tools lightning non-malicious means such as permission ops and side channel analyze. The keyword is under security sandbox analytics penetration testing ADB rename permission side channel digital forensics. The first one introduction. The theoretical report under which sandbox architecture and application solution outline a robust monitor layer defense model. However, true understanding in cybersecurity comes from practical engagement. This project is motivated by the needs to empirical validate the turquoise the theoretical security cells made by Android and discussed in the report. Understand the ethical positive to better defined system by safely attempting to perhaps security control. We learn their failure models. Demonstrate the defense in the best predicament by showing how to failure or pipes of one layer ng ag the permission model can be continued by another Synlex. We will advance security research mandates using a lecture penetration testing methodologies to probe the snakes boundaries in controlled lab environment. Number two, the project of objects and jewels. Number three, the functional analyze to create a set of tools and products to feasibly demonstrate the external and the environment of each sandbox layer. UID isolation promising synlex. Number 4, isolation vibes attempt. The design and implement non-destructive proof of convict POC application that attempt to prevent isolation, focusing on obsing of really promising and probing for information leaks via side channels. Number 5, forensics data collection. To use underweight built in the logit and other tools to collect evidence of both secure events and potential vibes. Number 6, comparative analyze to test the same proof application on different underweight free zone, underweight 8, we underweight on underweight 30 and 13.
3. 8. Methodology and technical approach. The project will be divided into distinct phases, each targeting a specified layer from the report. Phase 1. Environment setup and tooling. Devices. We will use multiple Android virtual devices with different API levels and one physical rooted device for advanced testing. SE Linux policy changes. Tools: Android Studio, Android Debug Bridge, ADB, PSIS, IZ Launchpad, DAMSys and terminal emulator on the devices. Phase 2. Probing the Linux kernel, Sandbox, UID, GID, isolation. Activity: develop two simple apps, APP-A and APP-B. Experiment 2.1. From APP-A, use the run as command or ps command via ADB to list running process. Phase 3. Testing the application permission model. Activity: develop a spy app that requires read external storage and access file location. Experiment 3.1. Pre-Android 6.0 AVD. Install the app and note that permissions are granted at that legitimately needs internet permission. Once granted, have the app attempt to extract a non-sensitive piece of data, e.g. fake device ID, to simulated command and control server. This demonstrates how a granted permission can be used for a united purpose. Deliverable: a comparison table and video demo showing the behavioral difference in permission models. Phase 4. Investing Internet Component Communication, IGC. Export components. Activity: develop two apps. Vulnerable bank app with an exported activity that requires no permission and a malicious app. Experiment 4.1. The vulnerable bank app has an activity called view balance activity with
محمد الخليدي اتصل.
through the malicious app sends an
ما
explicit
تصلكش.
intent to launch this activity successfully, displaying the user's balance without any authorization. Experiment 4.2. Fix the vulnerable bank Experiment 4.2. Fix the vulnerable bank app by setting Android export false or adding an Android permission attribute. Shows that malicious app intent now fails. Deliverable code for both apps and demonstration of the bypass and its subsequent mitigation. Phase 5. Analyzing mandatory access control with CEL Linux. Activity: use ADB and rooted devices AVD with root access. Experiment 5.1. observation. Use IZ data CE Linux context of app data structures, not the unequal labels. This visually demonstrates the sandboxing. Experiment 5.2 enforcement, right? Enforcement, right? A simple native binary that tries to open 9 expected outcomes deliverables, a final technical report PDF detailing the methodology, experiments, result analysis for each phase. This will be an extension of the provided theoretical report now filed with empirical data. A suite of Android application APK source code, the collection of test apps APP, spy app, vulnerable bank app, molecules app at ATG, developed for the experiments, a presentation live demonstration, a 15-20 minute presentation summarizing the project, followed by a live demo of the most compelling experiments, e.g. by spying and exported component showing an CE Linux Daniel, a video recording, a screen recording of the full demonstration, serving as backup and potential technical resource.
And now we're gonna continue about the Android of project of Android of operating system. Now we are gonna talking about the fifth phase and then sixth phase and the summary of these all operating systems project. Analyzing mandatory access control with the Linux. It's an activity that uses an ADB and rooted device as AVD with the root access. This experiment that's called shortly ADB or observation uses is data to review the Linux context of this application directors environmental on our own devices. No harmful code. The developed application will be designed from educational for educational proof. This developed application will be designed for educational proof of concept only. They will not contain actual malware or casual damage. And then focus on defense. This ultimate goal is to understand and improve the defenses not created only, but they created and exploit the focus of defenses of technical consideration. So these mitigation strategies of every basis we demonstrated to improve for like educational purposes, understanding and improvement, and then controlling it. So from all of these things, the conclusion of it is that this project offers a challenging yet highly educational path to deeply understand one of the most critical security models in modern computing. By talking this theoretical framework of the Android sandbox, by taking the theoretical framework of this Android sandbox and subjecting it to the practical hands-on testing, will be bridge the gap between academic knowledge and real-world security experts, the producing a valuable body of work of ourselves and the wider learning community. So this is taking about it the theoretical framework of an Android sandbox and Linux that we just talking about it. To use it is as a practical to hand testing and gap between it to the academic knowledge for educational and real world security expertise, producing a valuable body of work for ourselves and wider learning community. So that's it, and that is the Android Synlex and some of the shortly explaining about the fifth and sixth phases of the Android developing of operating system. And that's it. Thank you so much.